Today I'll be covering the Unit 6 review for pre-calc. How I'm going to do these first three is I'm going to start all three of them and then have the viewer try them on their own. Right, so one of the most helpful things you can do when starting these problems is to label all the information it gives you. So angle C is 20 degrees, angle B is 10 degrees, and side C is 33. Remember that side C is always across from side or angle C, and same for side A and side B. So we need to find side A, side B, and angle A. Since this is a angle side problem, we're going to start with the law of sines. That's how we're going to attempt this one. To do so, we're going to need angle A at some point, and since we know that triangles add up to, the angles in a triangle add up to 180 degrees, I'm going to say A equals 180 minus 20 minus 10, which is 150 degrees. Right? So we can use that fact to help us with the law of sines. For example, if we wanted to find side A, we would do sine of angle A, which is 150, over side A equals, and since the only side and angle pair we have is C, we're going to use sine of angle C over side C. And we can solve this for A, and once we do, we'll get an answer, and I will come back to that in a little bit. But I want to get 2 started, so moving on to number 2, again labeling our stuff. We have side A, we have side B, and we have side C. Alright, this time we have side, so we'll use law of cosines. We only use law of cosines, or we should use law of cosines if possible. Law of cosines is the only thing that will work if we have side, or side angle side. And if we're given 3 sides, we usually want to start by trying to find the biggest angle. So that's angle B in this case. How we can tell is that it's across from the biggest side. So the cosine of B, and you will get these formulas on the test. You can fill in A, B, and C. It will be 2.5 squared plus 4.5 squared minus 5 squared, which is B. So A squared plus B squared minus C squared over 2 times A times C. Right? And then if you do the cosine inverse of all that stuff on the right, you can put that in the calculator. B equals the cosine inverse of the whole right side. Put that in the calculator. You will get angle B equals 86.2 degrees. Make sure you are in fact in degrees mode. That will make a difference. Otherwise, sometimes you'll get negative answers, and you'll be like, "This doesn't make any sense." So that would be why you're getting a negative. And I will come back and show you answers for the rest of number 2, and then number 3. We start with a side angle side problem, so we have 110. For angle B, we have side A, which is 5.0, and side C, which is 4.5. We want to start this one by finding side B, because that's the only stuff we have information for. So we can start that by setting it up as B squared equals A squared plus C squared, which is 5 squared, plus 4.5 squared, minus 2 times A times C, which is 5, times 4.5, and then cosine of B, which is 110. And again, you'll get these formulas. They are also in your packet on page 13. There's 6 of them for law of cosines. There's only really 1 for law of sines, but you'll get that one as well. If you square root both of these sides, you can get what B is equal to. So B will equal the whole thing on the right, which you can plug straight into Desmos. So B will equal 7.8. This is lowercase b. There's a misprint down here, so this is b. This will be angle A. So lowercase b is 7.8. Right? And I will pause the video there for those of you who want to try and finish these problems on your own. You can use law of sine. Most of these you will use law of sines as your next step. Make sure you're being careful about law of sines, as it can give multiple answers. Alright, I filled in the missing information in green on the right side. I did write law of sines for all of them. You could use law of sines to define all of them. You could use law of cosines to define all of them. Just make sure you're being careful about which thing you're using. So number 4 wants us to figure out how many triangles can be formed with the following measurements. So the first thing we need to do is compare. So all of these are going to be the ambiguous case with angles, one angle and two sides. First thing we need to do is compare the side that goes across from the angle and the other side given. So B is across from angle B. So if B is greater than C in this case, so if the side across from the angle given is bigger than the extra side it gave, then there's always going to be one triangle. Always going to be one. So in this case, that is not the case. B is less than C. So that means there's a possibility of 0 or 2 triangles as well. For this test, whether it's 0 or 2, we need to test to see whether C times the sine of B, so C times the sine of B, is greater than or less than side B. So we're seeing if 5 sine of 50 is greater than or less than 4. So this will equal, I believe, let's find out on Desmos. And Desmos will tell us, making sure we're in degrees mode, that this is 3.8. Right, so this is 3.8. If this value is less than side B, so 3.8 is less than B, then there are 2 triangles. If 3.8 was greater than B, then it would be 0 triangles. The reason for this is that number we just found is the minimum possible height for side B. If it was smaller, you couldn't possibly create a triangle. This is going back to some of the notes we took in section 6.1. But I'm going to pause the video here so you can try parts B, C, and D on your own. And alright, here are the answers for B, C, and D, along with the reasons for those answers. If you would like further explanation, please ask. Make sure you get your questions answered before test time. On the next page, question 5 asks us to find the area of this triangle. The area formula you'll get on the test will be 1/2 AB sine C. You may need to modify that slightly to fit your needs, because in this case we have side A, side C, and not side B. So we can really just do 1/2 times A times C times the sine of B. So it's 1/2 times the two sides times the sine of the angle between them. So we can fill this in 1/2 times 4 times 8 times the sine of 80. And you will get this formula on the test. I put this in a calculator. This is equal to 15.8 square centimeters. Right. And then question number 6 is a word problem. It asks us to find the approximate length of the marsh. Between side A, or point A and point C. It says a surveyor walks 425 meters from point A to point B, and the surveyor turns 65 degrees and walks 300 meters to point C. So it wants us to find this length. I'm going to call it lowercase b, right there. And the angle it gave us is outside the triangle, so it's not going to be immediately useful. So we do need to find this angle. So that's just going to be 180 minus 65, which is 115 degrees. Right. Now we have a side angle side case, so we can use law of cosines. So we want to set this up so we can find side B. We can set up the same way we started question 3 on the front side. This is side angle side, so B squared equals A squared plus C squared minus 2 times A times B times the cosine of angle B. Alright? And then again we can square root both sides. So square root. So B will equal about 615.1 meters, it looks like. Right? So these are basically just versions of the front side. The questions 1 through 3 on the front side, you're just finding a single length as opposed to all the parts of the triangle. Right? And then number 7 is another one. This one is going to be us finding the distance from P to Q, so the distance along the height of, or the slope of the mountain. So that's, I'm going to call that side R, because that's across from angle R on the triangle. So to do this, we don't have any side. We have one side length actually given to us. That's going to be side Q down here, 1,000 feet. We have 2 angles, so it's a pretty good guess we're going to use 2 angles in this. So law of sines is probably where we're going to go at, because this is an angle side problem, or an angle side angle, whichever way you want to look at it. So this is going to be a law of sines problem. So we do need to find an angle P, because remember, the 25 degrees outside the triangle isn't immediately useful to us. But that's just 180 minus 25, which is 155. And then we should have the angle across from our given side to be able to use law of sines. So we do need angle Q, which will be 10 degrees. Right? So we have angle Q, we have side Q, and we have angle R. So we can set this up as a law of sines problem, as the sine of angle R, which is 15, over side R, which we're trying to find, equals the sine of angle Q, which is 10, divided by 1,000. 1,000 feet. Right? We can solve this with some nifty cross multiply, so I can say R sine of 10 equals 100 sine 15. And if I divide by sine of 10 on both sides, I will get R equals 100 sine of 15 divided by the sine of 10. If I put that in the calculator, the right side there, I'll get 1,490.5 feet. Is about how long the mountain slope is. And yeah. So if you have more questions on this, feel free to ask. Otherwise, best of luck.